June 6, 1944, 0630 hours, USS Augusta, 12 miles off Omaha Beach. General Omar Bradley grips the bridge rail, knuckles white against painted steel, watching his assault waves disintegrate through field glasses. Machine gun fire rakes the surf. Bodies tumble in the foam. The metallic chatter of German MG-42s drowns out American rifle fire, single shots, bolt actions, men dying one bullet at a time. Bradley's jaw tightens. His boys are outgunned. The mathematics of firepower are written in blood across the sand. The sound cuts through everything else on a battlefield. Sharp, metallic, final, like a church bell announcing the end of prayer. It's the ping of an M1 Garand ejecting its empty 8-round en-bloc clip, that distinctive ring that echoed from Guadalcanal's steaming jungles to Berlin's rubble-choked streets. Each ping signals 8 rounds of .30 caliber destruction delivered faster than any bolt-action rifle in history. The clip flies out, spinning through cordite smoke, and the soldier's thumb finds another loaded clip in half a heartbeat. No fumbling with individual cartridges. No working a bolt handle. Just continuous, devastating fire that sounds like industrial machinery consuming the enemy. The numbers tell a story written in steel and mathematics. America produced 5.4 million M1 Garand rifles during the war. A river of semi-automatic firepower flowing to every theater where GIs fought. Compare this to Germany's primary infantry weapon, the bolt-action Karabiner 98K, essentially a Great War design firing 5 rounds before requiring manual reloading. The M1's 8-round clip delivered 60% more ammunition before reloading, but the real advantage lay in sustained fire rates. A trained rifleman with an M1 could maintain 16 to 24 aimed rounds per minute, while his German counterpart struggled to achieve 10 to 15 with his bolt-action Mauser. Every engagement became a mathematical equation, where American soldiers multiplied their killing power by a factor of 2, sometimes 3. In jungle ambushes, desert firefights, and urban warfare, those extra seconds between shots meant the difference between advancing and retreating, between victory and casualty reports typed on carbon paper. The M1 Garand transformed infantry combat from a deliberate, methodical exchange into something resembling an assembly line of destruction, where the side with faster cycling mechanisms survived to fight another day. Springfield, Massachusetts, 1936. Inside the red brick walls of Springfield Armory, John Garand hunches over blueprints, adjusting tolerances measured in thousandths of an inch. The Canadian-born engineer has spent 14 years perfecting his gas-operated design, a mechanism that harnesses the explosive force of each fired cartridge to cycle the action automatically. Around him, machinists retool production lines built for bolt-action rifles, converting Great War manufacturing into something resembling a precision watch factory. Each M1 requires 47 separate machining operations, transforming raw steel billets into instruments of war through processes that mirror Swiss clockwork. Intelligence reports from Europe paint a grim picture. German infantry armed with proven Mauser rifles, Japanese forces wielding reliable Arisaka bolt actions. American soldiers still carry modified Springfield 1903s, accurate but slow, deadly but limited. The firepower gap yawns like a chasm that individual marksmanship cannot bridge. The M1 Garand emerges from factory floors as a masterpiece of mechanical engineering disguised as a soldier's tool. 9.5 pounds loaded, 43.6 inches of walnut and steel chambered for the powerful .3006 Springfield cartridge that can punch through light armor at 600 yards. The heart of the weapon beats with gas-operated precision. Fired gases tap through a port in the barrel, driving a piston that unlocks the rotating bolt and extracts the spent case while chambering the next round. All automatic, all faster than human reflexes. The N-block clip system holds 8 cartridges in a single metal frame that slides into the rifle's internal magazine with a satisfying click. No loose ammunition rattling in pouches. No fumbling with individual rounds under fire. Production data streams from multiple facilities. Springfield Armory manages 2,000 rifles daily. Winchester Repeating Arms adds another 2,500. Harrington and Richardson contributes 1,500 more. Peak wartime output reaches 4,500 M1 rifles rolling off assembly lines every 24 hours, each weapon proof-fired and zeroed before shipment overseas. Guadalcanal, August 21st, 1942. Dawn breaks over Henderson Field through layers of jungle mist that smell of rotting vegetation and aviation fuel. Japanese infantry probe American perimeter positions, expecting the methodical crack-pause-crack rhythm of bolt-action rifles. Instead, they encounter something unprecedented. The rapid-fire chatter of semi-automatic weapons delivering sustained volleys that sound like typewriters hammering out death sentences. Marine riflemen work their M1s like industrial machinery, each trigger pull answered immediately by mechanical precision. No bolt to work, no pause to reload individual cartridges. Just continuous fire that transforms infantry combat from careful single shots into something resembling suppressive barrages. Japanese soldiers, trained for close-quarters combat where bolt action limitations matter less, discover that American firepower creates kill zones where advance becomes impossible. The mathematical advantage plays out in muzzle flashes, 8 rapid shots from concealed positions, then the metallic ping of empty clips ejecting, followed by fresh clips slamming home in seconds. Enemy fire slackens. Bodies accumulate in the jungle undergrowth. The M1 Garand announces its arrival in the Pacific with a lesson written in ballistics and blood. Berlin, September 1943. Wehrmacht engineers study captured M1 Garands in sterile laboratory conditions, measuring cyclic rates and dissecting gas-operated mechanisms like surgeons examining a patient's heart. The implications terrify German high command. American infantry possesses firepower superiority that negates traditional defensive tactics. Hugo Schmeisser accelerates development of the Sturmgewehr 44. Germany's desperate attempt to match semi-automatic capability with selective fire versatility. Japanese forces adapt differently, emphasizing night infiltration tactics where individual marksmanship matters more than sustained fire rates. Their doctrine shifts toward close-quarters combat and surprise attacks that minimize the M1's range advantages. Like water flowing around obstacles, enemy tactics evolve to exploit the few remaining gaps in American firepower dominance. Supply chains strain under increased ammunition consumption as GIs burn through .30-06 cartridges at unprecedented rates, forcing logistics officers to recalculate tonnage requirements for every theater of operations. The M1's mechanical complexity breeds new problems in hostile environments. Pacific humidity penetrates the rifle's intricate gas system, like poison seeping through precision-engineered components. En-bloc clips corrode in salt air, feeding mechanisms jam with tropical moisture. And the 8-round capacity creates a distinctive tactical vulnerability. The metallic ping of empty clips alerts enemy soldiers to reload timing. Experienced Japanese infantry learn to time their advances with clip ejection sounds, exploiting the brief seconds when American riflemen fumble for fresh ammunition. Garand thumb becomes a painful rite of passage. Careless soldiers trap their thumbs between bolt and receiver during loading, the rifle's powerful operating spring slamming shut like a mechanical vice crushing bone and flesh. Field maintenance requires more attention than bolt-action simplicity. Gas cylinders need regular cleaning, operating rods demand lubrication, and the rifle's weight, 9.5 pounds loaded, exhausts soldiers during extended jungle patrols. Medical reports document repetitive stress injuries from sustained semi-automatic fire. Trigger fingers cramping like overworked pistons in an engine running beyond design specifications. Kasserine Pass, February 20th, 1943. American forces meet German armor and veteran infantry in Tunisia's rocky hills, where tactical inexperience negates technological advantages like fog obscuring a compass needle. Green GIs clutch their M1 Garands, but lack the combat wisdom to use superior firepower effectively. German 88mm guns tear through American positions, while experienced Wehrmacht infantry exploit poor positioning and inadequate coordination. Firepower superiority means nothing when units scatter under artillery bombardment or fail to establish overlapping fields of fire. The M1's rapid-fire capability becomes irrelevant in chaos, where soldiers cannot identify targets or coordinate movements. After-action reports document the harsh lesson: weapon superiority negated by tactical failures and insufficient combat experience. Second Corps After. Action Report, March 3, 1943, National Archives. Bodies litter the desert floor, each corpse clutching an advanced rifle that could not compensate for leadership failures and unit cohesion breakdowns. The mathematics of firepower require tactical multiplication factors that inexperienced troops cannot provide, turning technological advantage into bloody defeat when human elements fail to mesh like gears in a broken transmission. Veteran soldiers develop loading techniques that prevent Garand thumb, using the heel of the hand to push clips home while keeping fingers clear of the bolt's crushing path. Squad leaders create new fire and movement doctrines that exploit the M1's sustained fire capability. One team advances while another provides covering fire, leapfrogging across battlefields in coordinated bounds that maximize semi-automatic advantages. Supply officers redesign ammunition distribution systems, establishing forward dumps that can feed the M1's voracious appetite for .30-06 cartridges. Field armorers improvise cleaning kits from salvaged materials, using parachute cord and torn fabric to maintain gas systems in jungle conditions where regulation supplies fail to arrive. Combat experience transforms the rifle from a precision instrument into a battlefield tool. Soldiers learning to field strip and reassemble their weapons blindfolded, treating mechanical components like extensions of their own bodies. The M1 evolves through combat feedback, each engagement teaching lessons that filter back to training camps and replacement depots, where fresh recruits learn from blood-bought wisdom. Operation Bagration, June 23, 1944. Soviet forces equipped with American Lend-Lease M1 Garand's punch through German defensive lines in Belarus like hot steel-piercing thin armor. The concentrated firepower of semi-automatic rifles creates breakthrough momentum that bolt-action weapons cannot match. Red Army infantry advancing under sustained covering fire that sounds like industrial hammers reshaping the front lines. German positions, designed to withstand methodical bolt-action probes, crumble under the mathematical reality of doubled, tripled fire rates. Each Soviet squad delivers firepower equivalent to a German platoon. The M1's 8-round clips emptying faster than defenders can acquire targets and return effective fire. Radio intercepts capture German officers requesting reinforcements, their voices tight with disbelief. They have automatic weapons at squad level. German 9th Army Communications Log, June 24, 1944. The breakthrough cascades like dominoes falling, each collapsed position exposing the next, until entire army groups retreat westward through dust clouds that taste of defeat and burning equipment. Mathematics finally finds its perfect expression. Superior firepower properly applied by experienced troops creates tactical results that no amount of defensive preparation can withstand. The final accounting reads like a ledger written in steel and statistics. 5.4 million M1 Garand rifles produced between 1936 and 1957. Service records spanning from World War II through Korea, where the rifle's semi-automatic fire proved decisive in close-quarters mountain combat. Every subsequent military rifle design borrows from Garand's gas-operated blueprint. The M14, M16, AK-47, and their countless variants all trace mechanical DNA back to that Springfield Armory drawing board where John Garand calculated tolerances in thousandths of inches. The weapon's influence extends beyond pure ballistics into tactical doctrine, training methods, and industrial production techniques that revolutionized how armies think about infantry firepower. Modern soldiers carrying polymer rifles with electronic optics still depend on principles John Garand perfected 80 years ago. Reliable gas operation, quick reloading, and sustained fire capability that transforms individual riflemen into force multipliers. The M1 Garand didn't merely win battles through superior engineering. It rewrote the fundamental equation of infantry combat, proving that in war's ultimate mathematics, the soldier who shoots fastest often lives to shoot last.